Dear students, today we are going to solve question number 10 of exercise 11.2. Exercise 11.2 gi question number 10 hingsiko. Find the angle between the following pair of the lines. The piriba nangi line sing sigi angle putho hai mamang the sutam greko. Angle between any two lines is defined as the angle between the two vectors acting along the lines. Nangi line to the ek tawraga leiba or nangi line sigi direction piba vector amamam leigi ko adugi vector singdugi angle duna angle between the two lines. So question number 10 Roman number 1 the first line r vector equals to 2I cap minus 5j cap plus k cap plus lambda times of 3I cap plus 2j plus 6k first equation later ko dudi nangi vector nangi line si de ek tawraga leiba vector se sigi last ki lambda gi multiple se hoiduni ko and let m1 vector is equal to 3I cap 2j cap and 6k cap be the vector parallel to the line 1 the parallel badune khale ko and equation of the line 2 se later and mu se nangi scalar dune let m2 components I cap plus 2j cap plus 2 times okay be the vector parallel to vector amawale ko be the vector parallel to kanada parallel oiba line to the parallel oiba dudi let theta be the angle between the two lines tangi line ani dugi marakta leva angle sa aina theta ne na khan taragadi this theta is given by the cross scalar product of m1 and m2 scalar product of m1 m2 na p duni ko cos theta is equal to m1 vector dot m2 divided by magnitude of m1 magnitude of m2 ngasagi m1 dot m2 ki formula se even ko cos theta angle between two lines service the always positive quantity oy duna modulus sign law ne m1 and m2 components of m1 3I cap plus 2j cap plus 6k and the components of m2 1I cap plus 2 times of j cap plus 2k later ko m1 dot m2 is the sum of product of corresponding component haven x 1 3 into 1 3 fange ko 2 into 2 4 and 6 into 2 is equal to 12 divided by magnitude of m1 magnitude se kaina pi square root of x component square plus y component square plus z component square ni x component 3 square 9 2 square 4 6 square 36 and magnitude of m2 1 square 1 2 square 4 2 square 4 smai ito ko 3 plus 4 plus 12 is 19 and 36 plus 4 49 dareko 4 4 8 plus 1 9 the square root of 49 is 7 square root of 3 is equal to 9 is equal to 3 laireko positive ngata oirabanina 19 by 21 ere cancel to we have yadreko and therefore theta is given by cos inverse of 19 by 21 sinangi angle neba this is the angle between the two lines so main taraga khoina m1 gi m2 ga doina anka hot kaniko sinangi line sing se vector form the pyramid. Next question number 11. Find the angle between the following pair of the lines if the equation of the lines are given in Cartesian form. Handag na kaidoy na pi Cartesian form the p ko. Question number 11 gi Roman number 1. Equations of the lines are first write the equation of the given lines line 1 and the line 2. In Cartesian form equation of the line is x minus x1 by a, y minus y1 by b and z minus z1 by c where a, b, c are the direction ratios of the vector acting along the line hai given ko si a ni sin b ni sin c ni dudi ma se components of m vector oiduni let m1 represents the vector acting along the line the components of m1 will be 2I cap 5j cap minus 3k cap ireko then the direction cosines of the second line will be minus direction ratios of the second line will be minus 1 plus 8 and the 4 minus 1 ga 8 ka 4 ga oidune minus 1 I k plus I times of j k plus 4 times of k sumai phange ko dodi m1 gi component phange m2 gi component phange m1 m2 means the vectors acting along the two given lines oidune let theta be the angle between the two lines then this cos theta is given by m1 dot m2 divided by magnitude of m1 magnitude of n2 then take the modulus of this expression. First write the components of m1 components of m2 ireko find the magnitude of m1 2 square 4 5 square 25 minus 3 whole square plus 9 magnitude of m2 minus 1 square 1 8 square 64 4 square is equal to 16 then find the scalar product of these two vectors. Scalar product of two vectors in terms of their component is equal to sum of product of corresponding component 2 into minus 1 minus 2 5 into 8, 40. Minus 3 into 4 is equal to minus 12. Then find the value of this expression. 12 to 14 plus 40 direct difference 26, 30, 38, aduga 81. 81 gidi 9 fange nangi perfect square se ko. Square root of 81 is equal to 9. Then 38. 38 se dum 38 in later ko 38 se 2 ga 19 ga ni 2 su prime number ni 19 su prime number ni ko nas again reduce to we adre ko, and therefore theta is given by cos inverse of 26 divided by 9 root over 38. This is the angle between the given pair of the lines. Nang on the pair of the lines to gi angle se si orani ko. Now we are going to solve question number 12. Find the values of p so that the lines 1 minus x by 3, 7y minus 14 by 2p, z minus 3 by 2, and this equation are at right angles. The p-rival line and is right angles the later find the value of p. P ki value put o have. Here equation of the lines are nang nahan bada tawdu equation of the lines in san ithok 1 minus x by 3, 7y minus 14, 2p, z minus 3 by 2. Koina general equation of the line hairaga kayo na khange. General equation of the line se x minus x1 by a, y minus y1 by b, and z minus z1 da kaina divide over c ni ko. C ni koina khange general equation of the line se adu sima general equation the laibra laitre ko x na first term ga laiga tab se general equation have the x minus x1 by a, y minus y1 by b, and the z minus z1 by c have neba si x na mamang thangbra thangre sida y gi coefficient ya or sida di my the general form the laser ko sida koina x ka 1 ga interchange tawge haitardi we should multiply denominator and numerator by minus 1, and so 1 minus x by 3 can be expressed as x minus 1 by minus 3. Sigi term sigi expression si katang da minus 1 na multiply tawre ko sida na mo y gi coefficient se kya lere 7 lere ko 7 se 1 ohen ge haitardi we should divide both side denominator and numerator by 7 na divide tawre y minus 2 divided by 2p divided by 7. Mathang makha loin tawgadam ni ko asi the general form the later. Then and second equation se mo is second equation of the line is 7 minus 7x by 3p, y minus 5 by 1, and the 6 minus z divided by 5 ni ko. Sisu standard form the ige na khalagadi kamani iraktare x na mamang thangdoi ba ko x na mamang thangmaka na my coefficient se minus 7 later. Minus 7 later we should divide denominator and numerator by minus 7. We have x minus 1 and this 3p divided by minus 7. So ito is equal to sima ko na semninga yaudre y minus 5 by 1 tare. Then third expression gi 6 minus z by 5. Z na mamang thanga kadavane duna denominator numerator da minus 1 namana multiply tawre ko z minus 6 divided by minus 1. Sima gi standard form de loin later. Standard form the labadagi di nang nakaigi value itare write the values of m1 and m2 itare ko m1 haidi kaino m1 is a vector acting along the line 1 the act over nangi vector samane na components of m1 se minus 3 2p by 7 and 2i cap si thamme ko, and components of m2 are given by kanana pirakani 3p by minus 7 1 and minus 5 sina pirani ko 3p by minus 7 I k plus j k minus 5 times of k. See a b c ni sisu a b c ni ko direction ratios of the first line, direction ratios of the second line. m1 is the vector acting along line l1, m2 is the vector acting along l2 and sumain lo ko, and since the two lines are perpendicular nangi line ani se perpendicular oiba maramna m1 dot m2 se kya tani 0 tani ba. If the two lines are perpendicular, then the vectors acting along the two lines will be perpendicular, and so find the scalar product of m1 and m2. Minus 3 minus plus tare ko 3 9 by 7p, 2p by 7 into 1 is equal to 2p by 7 minus 2 into minus 5 is equal to minus 10 is equal to 0 tare ko. LCM lore 7 phange 9p plus 2p 7 into 10 is 70 equals to 0. By cross multiplication we have 9p 2p 11p minus 70 0 do the 11p is equal to 70 tare ko. Dividing both sides by 11, value of p is equal to 70 by nang p की value से 70 the 11 na divide tawre ko si kana की value arani which is the value of p nangi line ani duna perpendicular oiramagadi nangi vectors ani dusu perpendicular tani ko aduni m1 vector dot m2 se 0 haibasidagi khoina anka holaga p की value puthokpa ngamni. Next topic, distance between two skew lines ani gi marakta leiba distance haibani ko khona first ta kai define tawgani. First we have to define skew lines se define tawsiko. The lines which are neither intersecting nor parallel are called skew lines. Nangi lines se parallel su oidaba intersect su tawdaba lines sing se khoina kai kawe skew lines kawe ko. Staying se khoina ste line am ye ko. This line represents L1 and this line represents L2. L1 ni L2 ni line saiba se kaina line saiba se khoina small letters in the denote ko. It can be extended to any length. Masi any length the extend to ya doine sigi line ani se khoina yengbada parallel su ta de intersect su tawbra tawde ko. L1 and L2 are examples of skew lines ni. Skew lines ni ko. Skew lines size khangani intersect su tawdaba parallel su oidaba se. Sida khoina mo kai puthokani. Find the shortest distance between any two skew lines. Skew lines anigi marakta leiba khwaidagi tenba distance atenba shortest distance ni ko puthok tuise. Shortest distance se kamaina define to we have to mugengasi. Let L1 and L2 be any two skew lines and L3 be any point, any line which is perpendicular to both L1 and L2. Sigi L3 se L1 dasu perpendicular taba, kana dasu perpendicular taba, L2 dasu. And is the perpendicular over any line L3 habam laire ko. This line L3 se kai kawe. This line L3 is called the line of shortest distance kawe. Sigi L3 sina L1 se P da kai ko. L3 sina L2 se kya da kai Q da kai. Dudi PQ se PQ magnitude of PQ vector is the shortest distance between the two skew lines L1 and L2. L1 ga L2 ga gi marakta lairib shortest distance sigi PQ se tani dokhena anka hotpa kana vector do hot kani ko. The magnitude of PQ vector is the shortest distance between L1 and L2. Shortest distance sai se kaino khangani ko. Shortest distance sabadi definition gi matung ina CPQ se L1 the perpendicular tagani, CPQ se kana the perpendicular tagani, L2 the tani ko. Next topic, important ni ko asigi se find the shortest distance between any two skew lines. Skew lines ani gi marakta leiba shortest distance derive tawbagi formula ni ko asigi se important ni. Koina skew lines se ani lawra se L1 haiba maga L2 haiba maga. Let us consider any two skew lines L1 and L2 represented by the equation L1 R vector equals to A1 vector plus lambda times of B vector. L2 R vector equals to A2 vector plus mamang the lambda sijinagrabanina handak se mu haiba any scalar mapsiko mu lambda 2 vectors. Duga sumaina koina line ani gi eko equation si the A1 A2 haiba myaw. A1 position vector of the point S on the line L1 and A2 be the position vector of point T on the line L2. Sima fange position vector nen lawre ko. Let PQ be the shortest distance vector. Vector ni ko ina husik pirisa. PQ be the shortest distance vector between the two skew lines L1 and L2. L1 ge L2 ga gi marakta leba khwaidagi shortest distance oriba vector sa PQ vector sinen husik lawre ko. L1 the ek tawba se B1 ne. L2 the ek tawba se B2 vector ni ko. Koina ST join tawre. ST join tawba kana vector am phangani ba. Since the magnitude of shortest distance vector is equal to kaigamane. The magnitude of shortest distance vector is equal to the scalar projection of ST vector on PQ vector. Sigi ST vector sina PQ vector the label scalar projection ga maneba ko. Dudi kamai ithok pare sigi magnitude haita D na represent hole ko. Small letter D represent the magnitude of PQ vector which is equal to the scalar projection of ST vector on PQ vector. It will be equal to ST vector dot PQ vector divided by magnitude of AB. Mamang dasu aina takrabani ko. Scalar projection vector of A vector on B vector haibase A vector dot B haraga makada kaina divide tawgani. A vector dot B haraga magnitude of A habasina divide tawniba. Sigi formula si use tawraga A sina ST oitare B habasina PQ oitare ko divided by kanana divide tawgani magnitude of B. Magnitude of B na divide tawgadaba magi base where se ko si PQ se magnitude of B na divide tawthoe si B vector ni si A vector ni ko A vector divided by magnitude of B. Here ST vector means position vector of T minus position vector of S. A2 minus A1 tare ko. Since nang hauzik PQ vector si puthok tuineba. From the definition of shortest distance vector, this PQ vector is perpendicular to L1 and perpendicular to L2. PQ sa L1 the perpendicular oi, L2 the perpendicular oi. Adoi tardi si PQ vector se B1 the perpendicular tare, B2 the perpendicular ore ko. The cross product ki matung ina PQ vector is given by kaina piraani B1 cross product and B2 cross product. If a vector is perpendicular to both any two vectors, then that vector is given by the cross product of two vectors to na pirakani. Chi concept sima kuna cross product tagi laure ko. Dudi si ST gi value phange expression phange PQ gi expression phang taradi D have expression si da si ko. D is equal to A2 vector minus A1 dot. This PQ vector is to be replaced by B1 vector cross kaina sintare B2 vector divided by magnitude of B1 cross magnitude of B2. Distance I will say distance is always a positive quantity. Positive quantity we should take the modulus of this expression. A2 vector minus A1 dot B1 vector cross B2 modulus oina lawni ba ko ani sige expression se plus oina tarakpa yai minus oina tarakpa yai ba but kaidawa value the positive lawni. A1 khange ko A1 is the position vector of any point on the line L2. A2 is the position vector of any point on the line L2. Amana L1 the leba amana L2 the leba. B1 is the vector acting along the line L1. B2 is the vector acting along the line L2. Cross product lobagi concept hairani ko. Sigi formula sina kai P hairakanda distance between any two skew lines. Skew lines ki distance B gani. Next topic. Find the distance between two parallel lines. Nasai skew lines parallel soidava intersect tawdava handagna parallel lines ki khuna distance puthok parallel oitaraga di L1 L2 se parallel oiba any two lines amane na khalo. Let L1 and L2 be any two parallel lines represented by the equations. L1 R vector equals to A1 plus lambda B vector and L2 is equal to R vector plus A2 mu B. So the BB lies since the two lines are parallel and so they are parallel to the same vector. Samanaba vector amada parallel tani bako duna B1 B2 haibagi mahuta B vector siren. So the line ani ko let us draw two lines L1 and L2 and PQ. PQ is the shortest distance between the two lines. Ani sige marakta leba ko adagi ten ba shortest distance se khuna PQ sinena lawre ko aduga A1 se kaino A1 is the position vector of any point S on the line L1 and A2 is the position vector of the point T on the line L2. Then we join ST join the vector form tawradra. Let PQ vector be the shortest distance vector between the two lines. Nangi two lines L1 ge L2 ge shortest distance vector sa PQ ne na lawre simakhange ko. Dudi nangi PQ si magnitude sa sina shortest distance between the two lines L1 and L2 se ta duinatra. Magnitude of PQ vector is equal to sigi nangi ST se sip tawre na khale ko T ga P ga coincides tawre ST ga sigi line se ga parallel oitaraga di right angle triangle ang form tawe. Right angle triangle se right angle 8Q ne adudi magi hypotenuse ne ST tarani ko and let theta be the angle between this ST vector with kanaga this B vector siga laibane na khaladi. So that A PQ habase theta sigi opposite sin tai ko. The sin theta gi formula seasonary. Sin theta is given by PQ divided by ST. PQ se opposite sin ni ST sin hypotenuse tare ko. The magnitude of this PQ vector is equal to magnitude of ST vector into sin theta magnitude haina laurani. Magnitude lauri se kaigino nangi positive quantity khatang logani negative log be adeva ko. You see ST vector ire, then magnitude of PQ vector is represented by D. D is the shortest distance between the two lines. Sigi sin theta se kana gi angle gi manung da lay haradi ST vector ga B vector ga gi marak da lay tra duna khoina dot ka cross ka apply to bakan da sin theta se kai da yawe cross product to yawe duna cross product ki formula ire cross product of ST vector and B vector will be equal to magnitude of ST vector magnitude of B sin theta into n cap, where n cap is any unit vector which is perpendicular to these two vectors. The magnitude labelina akoina magnitude logsile both side the magnitude or the magnitude of n cap se 1 tagrani. Then for left hand side magnitude of ST vector cross B vector divided by kaina divide togani magnitude of ST vector and magnitude of B sina divide toreko. Cancelling ST vector and ST vector from numerator and denominator, we have this ST has the position vector of T minus position vector of S, A2 minus A1 cross product of B lereko divided by kaina divide torani magnitude of B na sumaina. Sigi value se kai warani. This is the distance between the two parallel lines kana gi marakta leiba L1 ga L2 ga. Next, question number 14. Find the shortest distance between the lines. Lines ani pire ko. Line ani sigi shortest distance puto o have. The given two lines are R vector equals to I cap 2j cap plus k lambda. In the first equation. Second equation pire ko. First equation, second equation, ibadagi dekhoina kai itare. Write A1 means a point on the line L1 B1. B1 vector is a vector acting along the line. First line 1 the act over sina A1 oigada sina B1 sina A2 oire sina B2 smainter lore ko. Silor bu matung da ngasagi shortest distance between the two any lines sebase. Kai gi formula na P gi D is equal to A2 minus A1 dot B1 vector cross B2 divided by B1 vector cross B2 gi magnitude. Sina divide to given. Sina divide to tarage dukhana kana gi value puthok pasange A2 minus A1. A2 minus A1 subtract to nareko 2I cap minus J minus K cap minus I cap plus 2 times of J plus K subtract over the I cap minus 3J cap minus 2K fange. Then kai puthokani sida B1 vector cross B. B1 vector cross B haibase kai formula na P gani. B1 my component si lereko matang the B2 si component lejare I j k 1 minus 1 1 2 2 1. B1 ki component han ithokpa. B1 ki component se 1 minus 1 1. B2 ki component se 2 1 2. Expand to reko minus 3I k plus 0j k plus 3 times of k fange. Duna distance D haibase kai na pirakani A2 minus A1 ki formula iro dot. Find the cross product of B1 and B2. B1 minus 3I cap plus 0j cap plus 3k cap. Cross product of two vectors in terms of component. The expansion of a determinant tagi ko. Duga B1 cross B2 ki magnitude logsi ko. Sigi magnitude di minus 3 square 9, 0 square ki 0, 3 square ki 9 am phange. Anisina scalar product log tare ko 1 into minus 3 minus 3. Minus 3 into 0, 0, minus 2 into 3 is equal to minus 6. Minus 6 ka minus 3 ka di minus 9. 18 se 3 square into 2 the EBI ko 9 by 3 root 2. Si cancel tawra di 3 by root 2. Root 2 se rationalize taw tho di root 2 na denominator numerator da multiply tawre ko aduna 3 root 2 by 2 units pange. This is the distance between the two given skew lines. Nangi skew lines tani dugi marakta leva distance to 3 root 2 by 2 sina oigata. For today, let's end here.